Back of the review sheet, we're going to do number 38. Consider the three charges arranged in a triangle as shown below. A, what is the net electric force acting on the charge at the origin? And B, what is the net electric field at the position of the charge at the origin? So they're asking us two different things, the net electric force and the net electric field. So force and field are two different things. We also see we have a configuration of three charges. So there's a couple of things that we need to do. What I'm going to do first is I'm going to write my given. Now in the diagram, they don't call the charges like Q1, Q2, or Q3. I'm going to go ahead and do that. The reason I'm going to do that is when I'm working out the problems mathematically, it really helps if I call them 1, 2, and 3, or however many numbers they are, because in the equation this way I can put Q1 or Q2, and then I can put what distance is it. Is it R12? Is it R13? So you don't have to have a ruler. I'm just going to do it so it looks a little neater. And again, I just want to draw a straight line. I'm just kind of copying the diagram from the homework. And this is the x-axis and this is the y. So first, the one at the origin is the one I'm concerned about. And I see that one is positive. And since that's the one I'm doing all the calculations with, I'm going to call that one Q1. Then over here to the right, I have another charge which is also positive, and I'm going to call that one Q2. And then I see in my diagram, they tell me the distance between these two charges is equal to 0.3 meters. And then I'm going to draw my third charge, which is down here. And this charge is negative, and I'm going to call this one Q3. And then I also see that this distance here between these two charges is 0.1 meters. Then I'm going to write everything in my given. So now, in my given, I see that Q1 is equal to 5.0 nanocoulombs. So nano means 10 to the negative 9. So instead of trying to do a conversion and making a mistake, write it just as I see it, 5.0 times 10 to the negative 9 coulombs. Q2 is equal to 6 nanocoulombs, so Q2 is equal to 6.0 times 10 to the negative 9 coulombs. And then I see that Q3 is equal to negative 3 nanocoulombs, which is negative 3 times 10 to the negative 9 coulombs. Now this distance here, this is the distance between 1 and 2, so I'm going to say R12 is equal to 0.3 meters. And then this is between 1 and 3, so R13 is equal to 0.1 meters. And again, this will make it helpful for my calculations. So first they want me to find what is the net electric force acting on the charge at the origin, this one. So I want to find the net force. So the net force is all the forces, the resultant, acting on that one charge. Now let me just kind of draw to the side and let me pretend here's that charge here. So first, when I'm looking at the forces, I have to say between these two, this is positive and this is positive. Well, like charges, do they attract or repel? They repel one another. So the force that exists between these two is either going to point this way or it's going to point that way. Well, because these two are the same, that force is going to go this way, and this is called F12. Now, these are like charges, so because this is positive and this is negative, there is going to be a force of attraction. So that force is going to go like this, and this is going to be F13. Now remember, forces are vector quantities. They have both magnitude and direction. I can't just, when I calculate these two forces using Coulomb's law, I can't just add them algebraically. I have to add them vectorially. So let's go ahead and calculate those forces. So F12 is equal to K Q1 Q2 over R12 squared. So this is why it helps to write all this in my given, because now I can easily substitute it into the equation for Coulomb's law. So 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, 5 times 10 to the negative 9 Coulomb times Q2, which is 6 times 10 to the negative 9 Coulomb, all over that distance, which is 0.3 meters squared. So when I do that on my calculator, I should get 3 times 10 to the negative, is that what, yeah, 3 times 10 to the negative 6 coulombs. Newtons, sorry. Because remember that all forces are measured in newtons. And if I want to carry my units through and cancel them to check my work, a newton meter squared times a coulomb squared times a coulomb over a meter squared. So this cancels with that, these two cancel with that, and I end up with newtons, which is the correct unit for force. All right, now we have to find F13. So F13 is going to be K Q1 Q3 over R13 squared. So that's equal to 9 times 10 to the 9 Newton meter squared per Coulomb squared times Q1, which is 5 times 10 to the negative 9 coulombs, times Q3, which is negative 3 times 10 to the negative 9 coulombs, all over 0.1 meters squared. And when we do all that, F13 comes out to be negative 1.3 times 10 to the negative 5 newtons. Now we have two forces that are going so we have to find the resultant. So the resultant of the two forces, here's the way my forces are. So I'm just going to redraw them. Here's F12. From the head of this vector, I'm going to do the tail of the other, F13. And then my resultant, from where I start to where I end up, and this is going to be my net force. So remember, I cannot just add these two forces. I can't say algebraically this plus this, because they're in different directions. So I add them head to tail and I find the resultant. Well, this is a right triangle, so to find the resultant, I would use the Pythagorean theorem. So F, the net force, is equal to the square root of F12 plus F13 squared. So then I substitute in my values. And I get my net force, which comes out to be 1.3 times 10 to the negative 5 coulombs. Is that my net force? Yeah. Now, this answer is not complete, because all forces have magnitude and direction. So I have to find the angle in which it's acting on. So here's my angle, theta. I have opposite and adjacent, so I can say tan of theta is opposite over adjacent. Tan of theta is equal to opposite F13 over F12. So it would be F13 over F12. And then I put that in my calculator. 1.3 EE 5 minus divided by 3.0 EE 6 minus equals second tan, and it comes out to be 77 degrees. So what's my frame of reference? Well, this charge, this is the origin, this is the x and the y. So this angle here would be 77 degrees below the negative x-axis. That's my frame of reference, because this angle here is below the negative x-axis. That's only part A for this problem. We still have to do part B. Now that's why it's so important. Do you see how the more you write down on paper, the less likely you are to make a mistake? What is the physics involved in this problem? What's the physics? Well, the physics is this right here, Coulomb's law. That's the physics. The rest is that there's more than one force, and there's a lot of things that we're doing math-wise, but the only physics is that we're using Coulomb's law. Okay, now we're going to do the next part. The next part says to find, the part B says, what is the net electric field? Now, because we already found the force, we have a shortcut to do for part B. Because for part B, all we have to do is use the equation E is equal to F over Q, which is going to be the net force over Q1, because we've already found the net force on Q1. If we didn't already find the net force, it would be different. We could find the electric field from each one and then do the same process, but now this is extremely easy. So the net force was 1.3 times 10 to the negative 5 newtons divided by Q1, which is 5.0 times 10 to the negative 9 coulombs, and a newton per coulomb is our unit, and then we divide this on our calculator. Remember, you have to make sure you know how to use these. So 1.3 EE 5 minus divided by 5.09 change sign equals, and then I'm going to put it in scientific notation, second 5. So it says 2.55, negative 2.55. Oh, it's positive, 2.55, so 2.6 times 10 to the third, and then, I think I made a mistake pressing one of the buttons, and then it's a newton per coulomb, but this also has to have a direction. So the direction is the same as this, so it's going to be 77 degrees below the positive x-axis. It's going to be the same thing. Here, so let's just go through the steps one more time. 1.3, then I press my EE button. This is negative 5, so when I hit 5, then I have to make it negative. Divided by 5 EE9, and then equals. And then I have to put it second, 5, and correct scientific notation. So 2.6 times 10 to the third power. And that's it. That's this whole problem. Then we're done.